Okay, kids. Why are drugs bad for you?
I know. Drugs make you mean to everybody like a monster. Then you get real sick and skinny like a skeleton, and you can even die. Yeah, Mom and Dad will be so sad they'll cry for a long time.
That's right, kids. So don't buy them.
Growing up on public broadcasting, I got to watch a lot of public service announcements like these on TV. Since the 1980s, the US government has spent more than $1 billion on anti-drug PSAs, starting with Nancy Reagan's Just Say No campaign. PSAs like these wanted to ingrain a lot of messages into us about what people who took drugs and sold drugs were like. Those drugs being things like cannabis, cocaine, meth, LSD, among others. It's important to acknowledge the fact that these PSAs were often racist and classist, and research has shown that their scare tactics haven't actually been very effective in preventing children from getting into drugs. But even if we acknowledge all of that, the fried egg anti-drug PSA that might be the most widely recognized of its genre might still fall off the mark in terms of even metaphorical accuracy.
Is there anyone out there who still isn't clear about what doing drugs does? Okay, last time. This is your brain. This is drugs. This is your brain on drugs. Any questions?
Is your brain on drugs actually comparable to a fried egg? That's probably something that you have your own opinions about. But on this episode of the Hopes Podcast, we're talking about experimental research on psychedelics and cannabinoids for neurological disorders that might, scramble that fried egg theory. You're listening to the podcast for Hopes, the Huntington's Outreach Project for Education at Stanford. In each episode, we share stories that shed light on the history and current issues in Huntington's research. I'm Kat Ferguson, and today I present a podcast that I'm calling Fried Eggs, but that should probably be called What We Know About Psychedelics, Cannabis, and HD. Here's a brief overview on the recent history of the legality of cannabis and psychedelics in the United States. In 1970, cannabis was first categorized as a Schedule I drug under the Controlled Substances Act. Schedule I means that it has a high potential for abuse, has no accepted medical use in the U.S., and that there is a lack of accepted safety for its use under medical supervision. The Reagan administration doubled down on new laws enforcing and prosecuting users of controlled substances. In 1998, Prop 215 legalized medical cannabis in California. In 2012, Colorado and Washington became the first states to legalize recreational use of cannabis. Today, it's legal recreationally in 15 states. Notably, though, cannabis is still a Schedule I drug. As for psychedelics, in the 1960s, they were praised by researchers as the coolest new development in mental health care, specifically through psychotherapy, which is when you meet with a mental health care provider like a psychologist or a therapist and discuss your thoughts, moods, behaviors, and feelings. Dr. Timothy Leary of the Harvard Psilocybin Project started popularizing LSD with his students, and it spread among American youth. In 1966, though, LSD was made illegal, and the FDA shut down all research. MDMA also joined the list of banned psychedelics soon after its first human dose in 1976. Both LSD and MDMA remain classified as Schedule I drugs, and unlike cannabis, the possession, sale, transport, and cultivation of psilocybin mushrooms, MDMA, LSD, and other psychedelic drugs remain illegal across the majority of the United States. But just as groups advocated for the legalization of cannabis based on its health benefits, groups are now advocating for psychedelics like LSD and MDMA to be legalized too. Just this year, Oregon became the first state to legalize psilocybin magic mushrooms. Research on psychedelics is becoming more achievable, and psychedelics-focused research centers at top institutions like Johns Hopkins University are leading the charge in discovering psychedelics' benefits for brain health that researchers in the 60s were so eager to find. But are psychedelics and cannabinoids relevant to Huntington's disease? I first got interested in answering that question, or at least learning about the current experimental research that might get us closer to answering that question, when I spoke with a person who is gene positive for Huntington's disease about their own use of magic mushrooms.
One coping strategy for me that's kind of unconventional and not exactly legal, but I don't know. There's some pretty early evidence or preliminary evidence that psychedelics like magic mushrooms might be really helpful for people that are confronted with a terminal illness in terms of helping them to kind of reconcile with their condition, helping them with anxiety and depression is kind of the most pronounced effect, and kind of hoping people come to realizations about kind of what's meaningful for them in life. And so, I've definitely turned to that as one way of kind of being introspective, facilitating introspection, and enjoying life and kind of finding more meaning and appreciating what life has to offer more fully. We don't know if it could actually exacerbate the disease or if it could be beneficial, or maybe it's kind of neutral and maybe it would just more so help with kind of emotional coping of like helping people work through kind of the demoralizing aspects of diseases like Huntington's disease. I've taken psychedelics enough times that it's a fairly predictable experience for me. Certainly for some people, they might have kind of challenging, like bad trips or challenging experiences. It can be kind of anxiety provoking if you're not ready for that kind of experience, or it can kind of amplify whatever sort of emotional state you're in. So maybe not everybody would be ready for that. In general, they tend to have kind of a euphoric quality and promote a positive mood. So in general, it's going to be a good trip. And if you go into it with kind of the appropriate mindset, in a good setting, where you're not going to be confronted with things that might kind of derail your experience, I find it to be incredibly beneficial. To me, I think it's a potentially medicinal thing that I'm going to use as a coping strategy going forward, at least until I see any sort of evidence that it is not great for the disease progression or something like that.
Of course, that's just one person's experience, and it's important to remember that federally, magic mushrooms are still illegal, so unless you're willing to walk that tightrope or fly to Amsterdam, you're probably not going to be going down that path anytime soon. But hearing about this person's experience got me thinking, what is the experimental research on drugs like cannabis and psychedelics telling us about their therapeutic potential? What are the potential benefits for people with HD? It wasn't easy to find people who were working on this. After all, Huntington's is a fairly rare disease, and research on the therapeutic potential of psychedelics or cannabis is highly experimental. I started out by talking to Dr. Robert LaPrairie, a researcher on cannabinoids and Huntington's disease at the University of Saskatchewan.
My name is Robert LaPrairie. I'm an assistant professor and the GlaxoSmithKline CIHR Research Chair in Drug Discovery and Development at the University of Saskatchewan.
Dr. LaPrairie started his formal research training as a grad student at Dalhousie University in Halifax. His supervisor, Eileen Donovan Wright, was interested in Huntington's and was one of the first people to show that the type 1 cannabinoid receptor dropped off early in Huntington's progression. Today, Dr. LaPrairie's lab at the University of Saskatchewan is focused on cannabinoids as potential therapeutics in the context of epilepsy and pain, and he still works with Dr. Donovan Wright on Huntington's disease. Dr. LaPrairie also has recently started a smaller research project in his lab with his PhD student on modeling the chemical structures of psychedelics to determine their potential benefit to Huntington's and other diseases.
When we think about cannabinoids and Huntington's disease, one of the things we have to think about, or one of the things that I think about, is you have a state where the specific population of neurons is dying in the dopaminergic pathway ascending from the substantia nigra up into the cortex. And there are these medium spiny projection neurons in the globus pallidus that are dying. And we call these things dopaminergic neurons because they have dopamine, but they also have cannabinoid receptors. And those cannabinoid receptors are being selectively lost. Their normal function is actually to slow neurotransmission through that system. So they act as a braking mechanism to slow the whole works down. And without those, you lose the brakes, essentially. And one of the hypothesized reasons why individuals that suffer from Huntington's disease have choreiform movements and spasticity is that, you've lost that braking mechanism. And so if you're able to restore that system, if you're able to add in more cannabinoid or augment or boost what's left of the system, then it stands to reason that you'd be able to, come to some sort of balancing act and help those patients along. We have these two kind of complementary programs. One is looking at synthetic cannabinoids that we're trying to develop as new drugs, and the other one is looking at plant-based cannabinoids. And generally what we're seeing is this thing where we have synthetic cannabinoids that might be useful in certain disease states. Now, we've been targeting Huntington's disease, pain, and epilepsy primarily. And our synthetic cannabinoids are kind of neat because all they do is act to bolster or augment the body's natural endocannabinoid system. And in theory, on their own, they're not able to turn on the cannabinoid receptors by themselves. So in theory, they wouldn't get you high, essentially, but they would boost your body's own system. So normally your body's endocannabinoid system has a couple of really key physiological functions. It helps with sleep, it helps with appetite, and it helps with pain perception, or reduces pain perception. And there are some other things like anxiety modulation as well. But you walk kind of a narrow tightrope, because if you activate that system with something like THC or a spice cannabinoid, you're going to get intoxication, you could get substance dependence, these sorts of things. So being able to bolster the body's own system allows for those benefits to come in without producing these potentially unwanted side effects. We used a mouse model of Huntington's disease. They're called R62 mice. And in that mouse model, we either treated them with what we call a positive allosteric modulator for CB1. So this is a drug that, like I was saying, bolsters the endocannabinoid system. Or we treated those mice with THC. And what we saw was that in those animals that were given the positive allosteric modulator, we just call it PAM for short, those animals had a slower progression through the disease. Their progression through the symptom profile in those animals was delayed by about 2 weeks, which is, in those mice, is a long time. In contrast, the animals that were receiving a high dose of THC, they actually got worse. Pretty early on in their disease progression, we saw a spike in symptom severity, which goes along with this theory that, boosting up the system that's there is good. Going, what I would say colloquially, going overboard, not such a good thing. So specifically to Huntington's disease, what we want to try and do is have therapies available that help with some of the things that people experience. So it's not a cure, but hopefully a treatment. So being able to help with motor coordination and anxiety, being able to help stimulate appetite late in the disease. These are all things that have potential benefit. But again, it's that close tightrope walk, right? Because something like THC, and this has been shown in a couple of clinical trials done by others, something like THC might actually make balance worse because of its intoxicating effect. So you want to find that sweet spot, that balance where you can help without causing additional problems. I think the most realistic outcome that we're starting to see now is policy changes. A lot of people have this kind of pre-inclined notion that because it's natural, it's safe. And I think for any drug, whether it's caffeine or cannabis, you need to know where to use it, but just importantly, where not to use it. And so my hope with this research on the synthetics and the plant cannabinoids and the psychedelics eventually is that we'll get to a place where we can say, okay, in these people, this drug is probably helpful. It has more benefit than harm. But in these other people, for example, we're doing a study right now in pregnant rats. For these populations, pregnant women, for example, maybe it's not a good idea and it should be avoided. And so I think getting to that policy level where we can help healthcare practitioners make informed choices will be the most realistic change.
To learn more about the research on psychedelics and the brain, I spoke to Dr. Manoj Das, a researcher with the Center for Psychedelic and Consciousness Research at Johns Hopkins, and Dr. Kyle Ortigo, a certified psychedelic-assisted psychotherapist and research consultant who has worked in UCSF's Psychedelic Research Lab and psychedelic startups and nonprofits, and also collaborates with Dr. Bill Richards of Johns Hopkins. It's important to state that the support that Dr. Ortigo offers is strictly legal. Outside of legally sanctioned psychedelics-assisted psychotherapy, he provides support with meaning-making for harm reduction to people who have already had psychedelic experiences, and does not work with clients who bring illegal drugs into his office.
I'm Manoj Das. I'm a cognitive neuropsychopharmacologist at the Center for Psychedelic and Consciousness Research at Johns Hopkins.
I'm Dr. Kyle Ortigo. I'm a clinical psychologist and I practice in Palo Alto, California.
Dr. Das and Dr. Ortigo agree with Dr. LaPrairie that psychedelics, like cannabinoids, cannot be a cure for neurodegenerative diseases like Huntington's disease.
I think when people talk about specific conditions, which is most of the research right now, thinking about psilocybin for cancer-related anxiety, psilocybin for end-of-life depression. We started in this new renaissance in the hospice and palliative care world.
Obviously, if you're diagnosed with a neurodegenerative disorder, I think that you do face an existential crisis and some kind of, you will probably have depression. I don't know what the exact statistics are for Huntington's, but I know for Alzheimer's, I think it's quite high. And on top of that, you also have the actual degeneration, which can also probably cause certain depressive-like symptoms.
Rates of depression in individuals who are gene positive for HD before or after the onset of symptoms are estimated to be between 40 and 50%, and depression or sadness are often the first symptoms of HD that individuals and their families report.
At the same time, we're going into MDMA for PTSD, trauma. There's work on social anxiety for people with autism spectrum. And I know people are looking at different substances for these same conditions.
The current mode of administration of these psychedelic therapies for mental health is through psychedelic-assisted psychotherapy.
So based on the research, so this is based on the research in psychedelic-assisted psychotherapy, most designs, as well as a lot of the use in sacramental religious settings. So both of these settings, they usually talk about 3 phases. And in the research, we call them preparation, the medicine session, and the integration phase. And some studies have just 3, others have repeated medicine sessions. So you might be going back and forth between those prep, medicine, integration, something like that. So there are a few different designs. But the preparation phase is really focused on what it sounds like, preparing someone for the experience itself. And that's where you give an overview of what you may expect without trying to lead someone into clear expectations, because a lot of different things can happen. And we don't want to encourage people to have an experience that's different than what may naturally develop if we didn't give them a lot of clues about what could occur. So the preparation is really about how to approach the day, what one's intentions are, what the protocol will be, the basic stuff when things start, and giving some clues about how to go in and through some difficult and challenging experiences that may come up with psychedelics, which they do. And within mindful settings like the psychotherapy or sacramental settings, like there's a preparation, there's a container for those experiences, and they're temporary. Overall, these experiences are safe, but it's helpful to have support.
The actual rooms in which these sessions take place, they're kind of dimly lit, softer lights. But there's also, cool like landscapes and whatnot on the walls. Things that, it's just a nice, it looks like a living room, And with that said, you might say, oh, people would love to, stare at those things while tripping, but actually people have eye shades on and they lay on the couch. So, and they're told to kind of, keep the eye shades on and just remain, just inward, go inward. With that said, of course, if they have, they start getting anxious, they can, take things off and start talking to people. One woman who we work with, she's like the warmest person in the world. I'd probably come off as kind of an ass, and yet she's always super nice to me, and she's nice to everybody, and everybody knows that. And in fact, I remember even one of our participants, I remember they were like, oh man, can I talk to Mary again? After this, we were like, yeah, I think so. I imagine, at least for some of them, they're going to be more likely to kind of disclose a lot of their, traumas of the past or, deep, dark secrets or whatever, because she's such a just trustworthy, nice human being. She's not the only one. But that's an example of somebody that is just like extremely compassionate, and clearly people love her. So you get, multiple days of that. And then after the session, I think you come back in the next day. You probably come in a week later. There's several points of phone contact throughout. And so it's a really, just kind of warm sort of process that in itself almost certainly has a large effect. Patients with depression, for example, they probably lose some touch with, their social circles, and they kind of, at least some of them, they might withdraw a little bit. And now they're kind of getting this again over a period of, several months even. So, that's what that looks like.
There's a lot of silence during these sessions. Potential for silence. It's not like an active psychotherapy, at least with the classic psychedelics. So they're very long sessions. A lot of the focus is generally, when possible, to go to the inward experience. So there's not a lot of talking or conversation. There's encouragement to have the eye folds on and listen to the music and not try to interact or talk or use words. But that can vary for different people. Some people like to talk a lot, and sometimes that's helpful and important. Sometimes it's a sign of anxiety. So the therapists in those situations, they help encourage the person, offer suggestions or ask questions, but it's very gentle overall what the therapists do there. So the next day, sometimes in research protocols, or the next week, there are at least a couple of sessions of integration work. And that's where you really go into, so what happened? What was the experience like for you? What did you notice? What has been unfolding over the next few days or several hours since you had the medicine session? And that's where you start the meaning-making process. You think about the symbolic meaning of the various visions or even physical bodily sensations that people had, and just explore what that means. People can have amazing experiences, and it helps heal their depression. It opens their eyes to a big world out there that's there all along. Just going outside and staring at the trees as the wind flows through leaves, like that is a beautiful experience, and we don't give much time to that. What the research has shown is that going through the psilocybin-assisted psychotherapy, MDMA-assisted psychotherapy, leads to increases of openness to experience, which is a personality factor that, in full disclosure, is one of my favorite. So I see it as a very healthy and positive change. But what openness to experience is about is like intellectual curiosity and openness to ideas, openness to one's values, kind of deeper reflection, new experiences. There's lots of different components of openness to experience. And with at least MDMA-assisted therapy, there's a decrease in neuroticism, which is anxiety, depression, hostility. There's a lot of different facets of that too. So these are generally viewed as positive changes, and positive in that they increase one's flexibility psychologically and adaptiveness to the world and one's environment.
at least in the controlled setting, the making sure that people don't have a history of psychosis or bipolar disorder, with obviously with the massive preparation where at least you can trust the people around you, and, they've constantly made you feel good for the several days before you're actually, participating in a session under the influence of psychedelics. So at least in our Healthy study, where we looked at the enduring effects 1 week and 1 month later, people reported less negative affect and more positive affect 1 week later. And I think the increase in positive affect even continued up to a month. As far as other benefits, like, for example, with cognition, it's kind of unclear. We found that cognitive flexibility was increased in patients with depression. There was also a finding both in the depression study as well as the published Healthy Adult study where we showed decreases in the amygdala's response to emotional stimuli, which that's actually found with typical antidepressant treatments.
The amygdala is relevant to mental illness because it is the part of the brain where you can find that fight or flight response and mediates feelings of anxiety.
It does seem that, for at least with our patients with depression, it does seem to have a pretty large impact on improving their depression for at least a week, and most of them up to a month, and in some people even up to 3 months.
But how does all of this work? How do psychedelics make room for these experiences and opportunities for transformation of thought?
Stan Groff talked about psychedelics being non-specific amplifiers of unconscious content, and the unconscious is very diverse.
I think that as far as this idea of increasing within network, increasing between network connectivity is something else that people will talk about. It's kind of just a broad effect, and the networks that are increased, that the increases in between network connectivity happen they're not consistent across different studies.
A neuronal network is a set of interconnected brain regions.
These networks do interact without being on drugs, but they interact, when you're performing tasks. And so when you have like 15 subjects that are just laying around on drugs, they're doing all kinds of things. Some people are going to focus on a memory of their mom. Some people are going to be paranoid and wondering what the experimenter wants out of them. Some people are going to be focusing on the scanner sounds. And so you can have a whole range of things that happen. And then the average across these 15 subjects is something that, looks like some increase in between network connectivity that are inconsistent between studies, decrease in default mode network and some other within network connectivity. I think that perhaps the strongest evidence is that there's this idea of thalamic gating. So there's the thalamus, which all senses, I think, other than smell, go through the thalamus first. It's a little bit of a simplification, but yeah. So it's like, for example, the light hits your retina. From the retina, it goes to your thalamus, and then it goes to the cortex. Some people sort of consider the thalamus then to kind of be a filtering mechanism or a filtering structure such that it is now filtering information, and only the most salient, prominent information or the most, let's say, biologically relevant or the only things that your attention is focused on can now get through the thalamus easily. But then under psychedelics, you get more kind of coming through. And this isn't meant to be like, oh, psychedelics show you things you can't normally see. It's more like, no, these drugs make you more distractible. So now all the things that you could normally be good at filtering out can actually kind of creep in and cause distraction.
These experiences, they open up a critical period. That's what we think about it in developmental literature. So a critical period where you can relearn new lessons.
Another researcher at Johns Hopkins, Dr. Gul Dolan, also speaks about critical periods, but in a different context than for the purpose of achieving more effective psychotherapy.
Hi, my name is Gul Dolan. I am an associate professor of neuroscience at Johns Hopkins University School of Medicine. My lab studies social behaviors, and we're really interested in understanding how the brain encodes sociality at the level of synapses, at the level of circuits, at the level of, sort of what happens across maturation, brain development, and also across evolution. And we're really interested in trying to understand how these circuits normally enable social behaviors, but then also what goes wrong in diseases like autism that are characterized by impairments in social behaviors. We know from human studies that teenagers are very, very susceptible to things like peer pressure. But as you get older, it's not that you don't care about your social environment. There are a lot of very salient social information in your environment as you get older, but it's a less of a driving factor in how you decide to do things. So the example I give is that, as you get older, you kind of, wear comfy shoes, even if they're ugly, because you just don't care anymore, like whether or not people are going to judge you based on that. This pattern of having a peak and then a decline in the amount you can learn from your social environment is something that we have seen in other contexts as well. And that change in your receptiveness to your environment has been called critical period. And so there are lots of critical periods in the brain. So the most famous one, and probably the one that's most familiar to people, is that, when you're young, you can learn lots of different languages depending on what environment you're in. But as you get older, trying to learn another language is much more difficult. And even if you do, you learn it with an accent. We were able to correlate the open state of the critical period and the closed state of the critical period with synaptic plasticity in the nucleus accumbens.
The nucleus accumbens is the reward center of the brain. It deals in the neurotransmitters dopamine and serotonin, the production of which can be affected by drugs like psychedelics and cannabis, as well as rewarding stimuli, such as social interaction.
The oxytocin-dependent synaptic plasticity in the nucleus accumbens, we saw it had the greatest amount of plasticity when the behavioral plasticity or the behavioral learning and memory was at its maximum. And then as the animals matured and the behavioral critical period closed, this oxytocin-dependent synaptic plasticity also went away. And so we like that as at least one mechanism that kind of might help to constrain this learning and memory to a specific window of development. And we thought, well, can we use this information to reopen the critical period later on in life? And so before I explain to you what we did to reopen it, I should state being able to reopen critical periods has been a dream of neuroscience for decades, at least 30, 40, 50, maybe even longer. And the reason is because neuroscientists have had a sneaking suspicion for a long time that we keep coming up with these great ideas for how to cure diseases. And we do all this research and all this study in animal models of these diseases. And then we go to clinical trials and they always fail. And one intuition people have had, or one worry or idea that people have had about why that's happening, is because whereas in animal studies, we do the experiments and we kind of figure out the mechanism and do our intervention very early on, typically. In human studies, we have to try all of these interventions typically in adults first, right? For ethical reasons. We don't go straight to children if we haven't been able to show that whatever we're doing is having a benefit in adults. But if the critical period for whatever disease that you're studying has already closed, the one that's relevant to the disease that you're studying, then that intervention might not work as well as it could if the critical period was open. So, probably an example that's familiar to people is that if you were born deaf and then you got a cochlear implant at some point, even if you can restore hearing, typically people who have their hearing restored have an incomplete recovery of their ability to process auditory information and also have impairments in the way that they are able to speak. And that's because those critical periods are closed by the time you give the intervention. If we could restore that balance at the same time as reopening the social critical period, then under those conditions, the drugs would work much better. That was sort of the motivation behind this idea that maybe we could reopen the critical period.
Dr. Dolan and her team knew that a mechanism that could potentially allow for reopening of the critical period was oxytocin-dependent plasticity in the brain, which is when the neurotransmitter oxytocin modulates the ability of the brain to change and adapt as a result of experience. Dr. Dolan and her team couldn't just administer oxytocin, though, because the neurotransmitter is unable to cross the blood-brain barrier, meaning that it would never actually reach the brain when ingested. Dr. Dolan did have another option, though.
There were these reports that if you give the psychedelic drug MDMA, that causes the oxytocin neurons in the hypothalamus of the brain to start lighting up and firing and becoming active. Then in a dose-dependent way, you get these increases in oxytocin release. So we thought, gosh, wouldn't it be cool if we could use MDMA to stimulate this mechanism that we have discovered in understanding the critical period for social reward learning. And that's what we found. We found that after 48 hours after we gave the MDMA, when we went back and looked at the adult social reward learning, which remember in saline conditions, in adulthood, they don't have social reward learning anymore. But after we gave the MDMA, then suddenly their levels of social reward learning had returned back to the way they were when they were juveniles. And so we saw that as evidence that MDMA is reopening the critical period for social reward learning. And so that is super exciting because I think that, to my knowledge, it's a totally new function of a psychedelic drug, that they might be returning the brain to this open state of the critical period. And it's really exciting for diseases like autism, where we might be able to intervene and combine it with other therapies that we think are correcting other imbalances associated with the disease. So what about other diseases? I mean, can we imagine that we can use this MDMA to reopen critical periods that are relevant for other diseases? Sure. I mean, we think that I think everybody during this pandemic has become very acutely aware of how important social behaviors are in our lives and how important it is to have social interactions with people, and how much they guide our ability to learn from the environment and also our sense of well-being. So, a lot of depression associated with social isolation, a lot of comorbid diseases that come with social isolation or neglect or maltreatment, including post-traumatic stress disorder, addiction, right? And so I think that those are sort of clear, easy to relate back to social behavior when we might see this having a therapeutic effect. But it might extend beyond that. And so currently in the lab, we are looking, first of all, to see whether or not, is it just MDMA that does this, or is it all psychedelic drugs, right? So one of the most important controls that we did is that we tried to reopen this critical period with another drug, cocaine, which is also, a stimulant, molecularly somewhat similar to, in terms of, proposed actions, to MDMA and amphetamine, but cocaine did not reopen the critical period. So it suggests that, there's something different about MDMA compared to cocaine. And then, I mentioned there are lots of different critical periods. So the other main area that we are pursuing is to determine whether or not MDMA and other psychedelics are able to open other critical periods that might be important for motor learning, for auditory learning, for visual learning, etc. And so to me, that if that's true, then it opens up the sort of therapeutic possibilities of psychedelics in a dramatic way that I think most people are not currently pursuing. And if they are, it's not for any mechanistic reason. It's just because, it's a new class of drug. Let's give it a shot. We don't have anything else that's working. But this really does suggest a mechanism for why that would be working. And it also suggests different ways that we might want to approach that clinically.
Clearly, there are a lot of theories on what psychedelics could do and how they work. As varied as the potential benefits of psychedelics are, though, it's important not to overhype them.
I had originally written saying that these drugs can treat depression, anxiety, OCD, PTSD, and sexual dysfunction. And my whole point with that was to be kind of hyperbolic, that I don't think these drugs are actually going to treat every one of these disorders.
When we start thinking of psychedelics as a panacea for all conditions for an individual, psychological or physical, medical, then we're missing out on the idea that it's really a catalyst more than a cure. I think being measured in expectations that it's actually going to cure a disease is something that we need to be respectful of too, because it's a disease like Huntington's that's a very serious diagnosis. When things are overhyped, then all of a sudden it becomes a magic bullet. It's going to be the cure. And then you set up these unrealistic expectations. And there may be powerful and wonderful things that happen, but if your expectation is just off scale, then it's going to be a disappointment.
It's also equally important to remember the dangers of psychedelics in uncontrolled settings. Dr. Doss mentioned running into a college friend who discussed his experience with psychedelics.
he had apparently in college at some point taken LSD and then attempted to chop his arm off with a machete. He said he didn't even feel it until he was in the hospital and he was essentially being wheeled, on a wheelchair. I don't even know if he said he felt it as much as he said, I think that's when he realized what was going on. And he said ever since, he said for a while after that, there was a really weird, like people talk about afterglow being a good thing. There was like a bad afterglow, I think. And then he even said he tried, I think like 2CI or some other psychedelic, and it totally like almost brought him back to that place where he was. He says even if he smokes cannabis now, he goes to a bad place. And I mean, he seemed fine, and I think he is fine, but that certainly had some kind of lasting negative impact on him, at least for some period of time afterwards.
And we see this in times past. In the 60s, there was lots of beautiful experiences people had when like LSD, for example, was legal. And then there was a lot of misuse because not respecting the power of psychedelics and not taking it in controlled, mindful settings, and then knowing what to do with these lessons. Someone I know and respect once was preparing people for a psilocybin journey in Amsterdam where it's decriminalized. And he said, you may have these epiphanies that it's all about love. And maybe that's true. And it's a lot more complicated too, when you bring that lesson into the world that's messy and complex.
All the researchers and the psychologists that I spoke to agreed. Psychedelics need to be studied more, particularly for Huntington's disease.
We know in individuals that suffer from Huntington's disease, we see this profound loss of medium spiny neurons in the substantia nigra. And that loss of neurons, they're very important to dopaminergic signaling, but they coordinate with those areas of the brain that, regulate mood, regulate addictive potentials or tendencies. And so from a kind of a neurological basis, there's good evidence for a tie-in, but we don't really know what that tie-in would look like.
Studying it more, though, is easier said than done.
I mean, historically, it's been super challenging to do research either on cannabinoids or psychedelics. There's just a lot of red tape around it, for better or for worse.
With the recent gradual legalization of many controlled substances, conducting research in these areas has become technically possible, but often comes with a lot of barriers in terms of getting permission to access the quantities of the drug that you need and administering it to human patients. Finding the funding for these research projects also often greatly depends on your institution and whether there is sufficient social interest in the topic. Beyond the legal complications, the nature of psychedelics themselves also make them difficult to produce a lot of information on in a short period of time.
I think the power of psychedelics is both the real draw in terms of the transformative potential and also the risk. We need to respect things that have a great deal of power psychologically. So that's the, I think, mindset of doing slow, controlled research studies. At the same time, those settings are slow. It takes a long time to really get clinical data and to look at all the various applications. Just in general in psychotherapy, we need to think about evidence, what we know from the research literature, and also know the limitations of the research and how when we work with individuals, different things may be relevant and impacting the care. You can't just go off of a manual if you're not also thinking about how to tailor something in an experience or psychotherapy for an individual. So it's always a collaborative process. There will always be edges of science that we don't know.
Unbiased research subjects can also be hard to come by.
So many people do take these drugs and they just never touch them again. And if they had this increased positive affect that, lasted for, weeks on end later, you would imagine that they would probably take them again, at least every once in a while or something, every time they're having a downtime or something along those lines. And yet a lot of people don't seem to actually get that. Although the survey research, all of the survey research people will, they do report that, I had a continuing afterglow that went on for, weeks or months or whatever. But those are also, a very biased population of people who clearly have an interest in psychedelic drugs. And that's why they're filling out these surveys. Same thing with this whole idea of having a bad trip. And actually all these people who had a bad trip, they say that it was, essentially worth it. But again, they're people who are into the psychedelic scene. So they fill out these surveys. A lot of people have bad trips and just never think about the drugs ever again.
Dr. Doss also questions the efficacy of the methods that many research groups, including those at his own institution, use as their primary method of clinical administration and research regarding psychedelics.
I think one aspect of it that I think needs to be at least somewhat finessed is the whole, what do we do with people while they're tripping? Currently, the model is at Hopkins, and I think this is true across most sites, is that they just lay on a couch with eye shades on. And they're on incredibly high doses, something 2 to 3 times the amount that people would typically take, in the streets, at least on their first trip. I think most people would take 2 grams about of magic mushrooms, or half an eighth or something like that. But they are getting, we don't know exactly what the equivalent is, but it's probably, as I said, 2 to 3 times that, about 30 milligrams of psilocybin, at least in many people's second sessions. And so, and I guess when people are on these incredibly high doses, it can be hard to do proper psychotherapy, but I think there can still be things that happen. And in some ways we sort of do this in those prep sessions. You kind of prime them into thinking about, well, what are all your problems? And, so they kind of almost are going to think about these things spontaneously while they're actually going through these sessions. But I think it's, there might be some use in explicitly cueing people while they're under, the influence of these drugs to think about these things and to talk about them and to kind of reconceptualize them in more of an explicit manner. And so I would just like to see how, what we can do exactly. Even with psychedelics, we might see some benefits from having people actually talk during these sessions, at least at some point in time. Maybe there's cycles of talking, going inward, etc. When you just have your eye shades on, you're not, appreciating, the physical reality of the world and all the crazy beauty you might get from, these drugs. Whereas that's what people always report. They say they go out into, nature, and it made them very much appreciate everything, and it was so beautiful. And, how do you kind of foster that when you're just laying on a couch with eye shades on? And perhaps that's not even necessary. I don't know. It's essentially based on very little to no evidence from a model that was, from the 60s and 70s. And I say that very little because the evidence is that, well, it works. And so this whole idea right now, if it ain't broke, don't fix it. And so clearly people are getting benefits without having to do all the things I just said, having, proper psychotherapy or queuing up their memories or whatever while they're under the effects of these drugs. But I think that, seeing more diversity in terms of how we administer, not just how we administer drugs, but what we're doing with people while they're under the influence, I think would be super valid in the future. And I think the research is in its infancy in all these areas, and hopefully we can kind of come up with, I think, a way to kind of facilitate these benefits while also kind of minimizing the harms.
Psychedelics, cannabinoids, and the brain are characters in a fascinating story that is only in its inception. After hearing about the benefits, dangers, and mysteries of psychedelics, you're probably not going to be ringing anybody up for a dose anytime soon, and you probably shouldn't. If you or a loved one is going through depression or anxiety, know that controlled psychedelics as a therapy are still in experimental phases and aren't right for everyone. If you can, reach out to a mental health care provider who could introduce you to the many other therapies available that might be right for you. But keep an eye on this field. After decades of suppression, research in the field is growing. And as time passes, there may be more interesting news about the brain on drugs, in a controlled setting of course, that doesn't involve any metaphorical fried eggs. Thank you to Dr. Robert LaPrairie, Dr. Manoj Das, Dr. Gul Dolan, and Dr. Kyle Ortigo for your insights. As Dr. LaPrairie said,
I think it's important to remember that science is a team sport. On any one of these papers that we talk about or anything we've talked about today, we're talking about teams of researchers that are usually 10, 20 people. So I get to talk to you about it because I have the good fortune of leading this research, but it represents a whole bunch of people coming together to get stuff done.
We got to hear from some of those lovely people today, so thank you again for that. If you'd like to keep tabs on our speakers today, you can find Dr. Manoj Das at MANOJDOSS on Twitter, and you can hear more from Dr. Ortigo in his book, Beyond the Narrow Life, A Guide to Psychedelic Integration and Existential Exploration, which is coming out this summer. Thank you to the Hopes Fund and Stanford for their support in my creation of this podcast. Thanks to Catherine Heaney and the Hopes team for all of your guidance. Thank you in particular to my interviewee, who spoke to you about his experiences with being gene positive and using psychedelics, and who provided so much support in researching and developing this podcast. If there is anything related to HD that you are interested in hearing about on the podcast, let us know in the reviews. I'm Kat Ferguson.
Wish I was up in Vancouver at the Cannabis Cafe, smoking good old Sensimilla at the beginning of the day. But here I am in New York City, hiding out in Central Park, getting kidnapped by the police today sometime before dark. But I wish I was up in Vancouver at the Cannabis Cafe, smoking good old Sensimilla at the beginning of the day. The judge looked down upon me, frowned. He said, "Kid, get on your way. Just don't start out your morning with espresso and a J." I said, "I wish I was up in Vancouver at the Cannabis Cafe, smoking good old Sensimilla at the beginning of the day." Hitched on out to Portland, caught a ride up to BC, took the bus over to the neighborhood to have a bowl with my coffee. Now I'm up in Vancouver at the Cannabis Cafe, smoking good old Sensimilla at the beginning of the day. Smoking good old Sensimilla